If one atom doesn't completely overwhelm the other, they can actually share each other's electrons. This is like a potluck, where you and a friend each bring a dish, and then both of you share both dishes. Each atom is attracted to the shared electrons in between them, and this attraction is called a covalent bond.
Next, we go to the second type of chemical bonds, which is covalent bond. Covalent bonds are a class of chemical bond where valent electrons are shared between two atoms, typically two nonmetals. The formation of a covalent bond allows the nonmetals to obey the octet rule and thus become more stable. The atoms are held together because the electron pair is attracted by both of nuclei. Now, consider the case of fluorine, which is found in group 17 of the periodic table. Fluorine has 7 valent electrons and only need one more in order to have an octet. One way that can be happen is if two fluorine atoms make a bond in which each atom provides one electron that can be shared between two atoms. The resulting molecule that forms is F2. After a bond has formed, each fluorine atom has 6 electrons in its valence level, which are not used for the formation of bond. These non-bonding valent electrons are called lone pairs electron and should always be indicated in Lewis structure. A single covalent bond can be represented by a single line between the two fluorine atoms. Single bonds occur when two electrons are shared and are composed of one sigma bond between the two atoms. Some simple molecule containing double bond, I use oxygen molecule as an example. First, you need find the valence electron by writing electronic configuration. So, the electronic configuration of oxygen atom is 1s2, 2s2, 2p4. Each oxygen atom contributes 6 valent electrons to the molecule. Drawing a single bond between the atom does not lead to valent octet. Each oxygen atom only has 7 electrons in its valence shell. So, how to solve this problem? This problem is solved by forming double covalent bond. Two oxygen atoms can both achieve stable structure by sharing two pairs of electrons. The double bond is shown by two lines joining the two atoms. Each line represented one pair of shared electrons. Double bond occur when 4 electrons are shared between two atoms and consist of 1 sigma and 1 pi bond. Some simple molecules containing triple bond are used. Nitrogen molecule as an example. First, find the valence electrons by writing electronic configuration. So, the electronic configuration of nitrogen atom is 1s2, 2s2, 2p3. Nitrogen has 5 valence electrons. So, it needs 3 more valence electrons to complete its octet. Triple bond occur when 6 electrons are shared between the two atoms and consist of 1 sigma bond and 2 pi bond. Covalent bond can be single, double, and triple bond. Single bonds occur when 2 electrons are shared and are composed of 1 sigma bond between the two atoms. Double bonds occur when 4 electrons are shared between the two atoms and consist of 1 sigma bond and 1 pi bond. Triple bond occur when 6 electrons are shared between the two atoms and consist of 1 sigma bond and 2 pi bond. Now we proceed to the third type of chemical bond, which is dative bond. A dative bond is also termed as coordinate covalent bond. Dative bond is a covalent bond in which the shared electron pairs is provided by one atom only and the other atom just accept the shared pair. In the formation of a simple covalent bond, each atom supply one electron to the bond. But a dative bond is a covalent bond in which both electrons come from the same atom. In the formation of a dative bond, other atom does not provide electron for sharing. So, it is one-sided sharing. The formation of dative bond belong to the atoms that have lone pairs of electrons. The atom that provide electrons is termed as a donor and the other which take the electron pair is called acceptor. Dative bond is represented by an arrowhead that points from donor atom to the acceptor. So, there is no difference between a coordinate bond and a normal covalent bond. They differ only in the way in which it forms. Next, we proceed with the third type of chemical bonding, which is dative bond. So, I choose the reaction between ammonia and boron trifluoride as an example. As we know, boron trifluoride is a compound which doesn't have a noble gas structure around the boron atom. The boron atom only has 3 pairs of electrons in its bonding level, whereas there would be space for 4 pairs. So, boron trifluoride is described as being electron deficient. The lone pair on the nitrogen of an ammonia molecule can be used to overcome that deficiency. One lone pair of electrons from nitrogen atom are shared for bonding. And a compound is formed involving a dative bond. In simple diagrams, a dative bond is shown by an arrow. The arrow points from the atom donating the lone pair to the atom accepting it.